Real exam questions. This is question 66. It's about the use of yield lines in slab design. Determine the maximum bending moment of a rectangular slab with side A and B, where A is the smaller than B. The slab is simply supported on all sides and use the yield line theory. If B is much larger than A, what is the maximum occurring bending moment now? And is this expected? Let's consider the rectangular slab. The axis of rotations are situated at the supports, at the four sides. When two axes of rotation crosses, the yield line starts. And because this condition is the same as this condition, it means that you have a 45-degree angle. So in each corner, you will have this situation. The two parallel the axis of rotation, they have an intersection on an infinity. So it means this is a horizontal connection between the two. The work done by the external forces is then the work done by this triangle, which means A times A over 2 divided by 2 multiplied by Q for the total load of this slab, and multiplied by the mean deflection, which is a delta over 3, because it's a triangle. We have two of them, so that's where the 2 is coming from. Then what's left are 4 smaller triangles, and there the surface is A over 2 times A over 2, half of it, and multiplied by the load Q, and the mean deflection is delta over 3, and this 4 times. What is left is this rectangular portion of the slab. There you've got A times this length, which is B minus A over 2, so B minus A, and the deflection, the mean deflection, because it's a rectangular, it's delta over 2. That's what's stated here. If you simplify this equation, then you've got the work done by the external forces. The work done by the internal forces, it's this bending moment M projected on this axis of rotation, which gives you M times B. And the angle of rotation is, of course, delta divided by A over 2. We got this 2 times because this is the same, and this is projected on this axis of rotation. And then what's left is this bending moment projected on this axis of rotation, which gives you M times A, and the angle of rotation is delta divided by A over 2. And we got this 2 times, this projected on this axis. When you work this out, you will have this expression for the work done by the internal forces. Now, E must be equal to D, and from this equation, we get M, and M is QH squared over 24 times a ratio, which is only depending on the geometric characteristics of the slab. Now, suppose that B is much larger than A, then you take the limit of this for B going to infinity, then 3 will be left. It will be 3B over B because those two do not contribute a lot. So you have QH squared times 3 over 24 or QH squared over 8. And this is the bending moment of a one-way slab in a direction of A. So that's what we are expecting to